Hey, hello and welcome to today's GFG problem of the day. Hope you're doing well. So let's see today's problem, stock span problem. Okay, so what the problem is saying is we'll be given an array which will contain the prices of a stock. Okay, the prices of a stock, the daily price of the stock. Okay. And what we want to do is we want to find out that till each given day. Okay, what are the number of stock prices less than or equal to this particular current day? Okay, so let's see. So for this particular day, okay, for this particular day, there is only one stock price which is 100. Okay, which is this price itself, which is less than or equal to the current day, which is less than or equal to the current day. So for 100 it is 1, right? For 80, for 80 it is 1 because 100 is greater than 80, and we want to find out all the stock prices lesser than till this current day. Okay, so 100 is greater, we won't consider 100, but we'll consider 80 for 80 itself, right? Till that current day, till that particular given day. Okay, the 80 is less than or equal to, okay, 80 or less than or equal to. Again for 60, it is going to be 1 only, that is 60, because both 80 and 100 are greater than 60. Okay, for 70, for 70 it is going to be 2. Which are those two prices? One is this 60 and one is the 70 itself. Okay, then comes this particular 60. Again for this one it is going to be 1 only, because 70 is greater than, 60. Okay, for this particular day there will be how many stocks? This is 1, 2, 3, and 4 itself, so 4 will count 4. Okay, for 85, now how many stocks are there? 1, 2, 3, 4, right? 5, and this particular 85 also, right? Which makes it 6. So 6. So this is our resultant output. Okay, so I hope you have got the ask. Now let's see how we can solve this problem. Okay, so looking at this problem, maybe you got the intuition that we can solve this problem using stack. So if you got that intuition, then you are bang on, right? So let's quickly solve the problem using stack. Okay, so what we're going to do, we'll take a stack. Okay, and we'll take a resultant list or resultant array. Okay, which will be our output. Okay, now first of all, for the zero, definitely for the 0 day it is always going to be 1. It is always going to be 1. That is a stock itself, that particular stock price itself. Okay, because there are no stock prices before this one, right? That is why 1 will be the first answer. And what we are going to do, when if the stock is if the stack is empty, this if the stack is empty, then we are going to ingest the the index, right? 0, 1, 2, 3, 4, 5, and 6. These are the indices. So we are ingesting 0. Okay, in this particular stack. Okay, now what are we going to do? We are going to move on to the next one. Okay, we are going to check, is 80 greater than the peak? For example, if this is air. Okay, air of I is 80. I is pointing here. Air of I is 80. We're going to check, is air of I greater than air of air of stack dot peak? Okay, or stack dot top in case of C++, right? In case of C++. What we are doing here is air of I, which is 80, greater than equal to air of stack dot top or stack dot peak, which means what is stack dot top or stack dot peak? It is 0. Air of 0. So what is air of 0? It is 100. Is 80 greater than 100? No, it is not. It is not. So what we're going to do here is, we are going to simply take I in order for this particular position to be filled, right? I minus stack dot peak will give you the number of days. Okay, will give you the number of days which have less than or equal to the current price. So I is 1, right? Stack dot peak or stack dot top is 0. So 1 minus 0 will give us 1. So 1 is the answer here. We'll go to the next one. Again, is air of I, which is 60, is it greater than air of stack dot? Oh, before going to the next one, we also have to push this particular index, which is 1. We'll push this particular index. Okay, now we're going to go to the next one. We're going to go to the next one. Now we're going to check here, is air of I greater than equal to stack dot peak? What is stack dot peak? Air of I is 60. Air of stack dot peak is 1, which is 80. Is it? No, it is not. 60 is not greater than 80, right? So what we're going to do, we're going to use this in order to fill this formula, I dot stack dot p. We are going to use, right? So I is 2, Stack dot peak is 1. So 2 minus 1, 1. So we're going to fill 1 for 60. Okay. And we'll also add the index of 60 to the stack. Now we're going to go to the next one. We're going to go to the next one. So now here, right? Here, what is, okay, R of I is 70 greater than equal to, R of stack dot peak again. So what is stack dot peak, which is 2, right? Stack dot peak is 2. It is 2. What is R of 2? Yes, it is R of 2 is 60, right? R of 2 is 60. Yes, 70 is greater than 60. So we will pop this out. Okay, we'll pop this out. Okay, this particular, since 70 is greater than 60, greater than equal to 60, we'll pop this out. Now we'll check, we'll compare with this one. Is R of I greater than R of 1, right? Which is a stack dot peak. R of 1. R of 1. R of 1 is what? 80. No, this condition does not match, right? 70 is not greater than equal to 80. Okay. So what we're going to do? Again, we're going to use one. R I minus stack dot P. Okay. So I is what? 3. I is 3. 3 minus 1, which will give us 2, which we are right? 2. For 70, it is 2 because 60 and 70. These are the stock prices which are less than or equal to the current price. Okay. And also what we're going to do? We're going to push this particular index, right? Now we'll come to this particular index, 60, right? Yeah. Now we're going to compare. Is R of I, again, is R of I greater than or equal to stack dot peak? R of stack dot peak. R of stack dot peak is what? Stack dot peak is 3. So R of 3 is 70. 60 is not greater than 70. So what we're going to do? Simple again, this one. I minus stack dot peak. What is I? I is 4. I is 4. 4 minus 3. Stack dot peak is 3. So 1. Okay. And we'll also push 4 to the stack. Now we'll come to the next one. Again, we're going to compare is R of I, this particular one, is greater than or equal to R of stack dot peak. What is stack dot peak is 4. R of 4. Right? So 75 greater than or equal to R of 4 is what? 60. Yes, it is greater, right? So we're going to pop this out. Okay, again, we're going to compare R of I, R of 3. 75 is greater than R of 3, right? We'll pop this out. Okay. Then we'll compare 75 greater than R of peak is stack dot peak is what? 1. R of 1 is 80. 75 is not greater than 80, right? Is not greater than 80. So we'll simply now I is what? 5. 5 minus stack dot peak is what? 1, which is 4. 4. So we are ingesting 4 here, right? Similarly, now we'll ingest 5 here as well. Now for again, we are going to compare. Yes, it is greater. 85 is greater than R of 5. R of 5, right? So we'll pop this out. And 85 greater than R of 1. R of 1. What is R of 1? It is 80. Yes, it is. We'll pop this out. 85 greater than R of 0. No, it is not. So simply I. I is what? 6. 6. Using this one, 6 minus stack of P, which is 0, will give us 6. Okay. So this is the intuition behind solving the problem. I hope you have got the intuition. Just one request to please subscribe to channel, like the video. Let's quickly go and code. So first I'll show the Java code followed by C++. Okay. So let's stack. Okay, stack integer stack equal to new stack. Okay, then we will have our result array new integer array dot length. Okay, plus I. Okay, now what we're going to do? So now first of all, result of 0 will be 1, as I already explained this. Okay, now we're going to compare is stack empty. If it is empty, simply return, simply add stack dot push I. Okay, stack dot push I. Else if stack is not empty, we're going to check here. While stack is not empty and R of arr of I is greater than equal to arr of stack dot p. All right. So what are we going to do here? So we just want to pop. We're just going to pop. Okay. For example, what is this condition? If and for example, if this was 85, right? And this was there, right? In the stack. So we are comparing. Is 85 greater than arr of 5, arr of stack dot p? If it is greater than, we are popping this out. That's what we have explained, right? So that's what we are doing here. We are popping. So now we're going to check here, is stack empty now after popping all the lesser elements? Okay. If it is, then result of I will be I plus 1. I plus 1. Else, result of I will be I minus stack dot p. Now just consider the case, for example, just consider the case. Okay. Now this was the case, right? What was the example? 100. Let's take this example again, 80. Let's for now consider that it was 83. Okay, 83, 80, 60, 70, 60 again, 75 and 85. Okay. And if this was the case, right? So 85, you can see it's bigger than all the other elements, right? If this was the case, right? If now 0 was left, we were at here at this particular position I, right? Now we are comparing here. Is arr of I greater than equal to arr of stack dot p, right? Stack dot p. So yes, so arr of I is what? 85 greater than equal to arr of stack dot p. Stack dot peak is what? 0. So arr of 0 is 83, right? 83. So yes, this condition does do match, right? This condition do match. So what we do when it is matching, we pop the element out, right? And okay, now we are going to break the while loop because stack is empty now. So when the stack is empty, so what we're going to do, whatever is I is what? 0, 1, 2, 3, 4, 5, and 6. Right? Whatever is the I, so you're going to do I plus 1 in this case. Because what we are saying is the answer will for this particular position will be I plus 1. Okay. So why I plus 1? So I plus 1 is I is what? 6. 6 plus 1, 7. So why 7 answer? So if you see, all the stock prices are less. 1, 2, 3, 4, 5, 6. Right? All the stock prices before this particular given day are lesser than the current day, 6. And this particular price, 85, is equal to, right? So we also consider this particular price as well. So 6 plus 1, 7. That is why 7 is the answer. And that is why I plus 1 when the stack is empty will give you. So for this condition, we didn't see, right? This condition. So this is for that. Okay. Okay. So yeah. So here what we're going to do, we're also going to push the current index element, right? Current elements index. Okay. So that's it. So here the expectation is to return array list. So that's what we're going to do now. So return new array list. New array list, arrays as list, result. Okay. So this is converting array into array list. Okay. So let's compile this. Let's submit it. Thanks for watching. Please don't forget to subscribe to the channel, like the video. Let's quickly see the C++ code as well. Okay. So here's the C++ code. Here we are taking stack. Here we are taking vector. Okay. And we are setting one as a first answer. For example, the answer for the first stock. Okay. For the first stock price. Then we are iterating through the array. We are checking here. Okay. We are checking here. Is if the stack is not empty and arr of I is greater than arr of top, stock dot top, then keep on popping the elements. If the stack is empty in that case, then for that particular uh, stock price, right, it is I plus 1 is the answer for that particular current day, for that particular day. Else, it will be I minus stack dot top. Okay. And at each given step, we want to also add the ith position, right, into the stack. Okay. And finally, we are returning the result. Okay. So this is it. Thanks for watching. I'll also attach the code in the description section. Please don't forget to subscribe to the channel, like the video. I wish you a very happy, healthy, wealthy, and a great day. Thank you so much.